Thanks, Jamie. Hi, everyone. Welcome back, everyone who's been before, and welcome to any newbies. So I'm Claire Spillman. I'm based in Melbourne on the lands of the Kulin Nation, and I'm at the Bureau. So Alistair's going to kick us off, so I'll pass over to Alistair, and he can take it from here.
Thanks, Claire. Hello from Nipaluna, Hobart. Often in these meetings, we talk about extreme events. But before I do that, there's a recap slide. And so I will do the recap slide rather than you, Claire. When last we met in January 2026, there was low risk of marine heat waves for the summer, and that's panned out as we'll show you. And so really encouraging that you use this time over the summer to think about either recovery or long-term planning for coping with extreme events. Part of that thinking about the extreme events and the recovery was thinking, if you're doing things like habitat restoration, how do you make sure that the species that you're restoring can survive the next event? And so we use the phrase of, building back better. And Melinda Coleman from New South Wales Primary Industries talked about a new tool called Reef Adapt, which is used to help conservation practitioners choose where they might source material for revegetating an area. And using kelpers as an example, if you're restoring in the peninsula area of Victoria, you might choose to source your stock from around the corner with the border with New South Wales and Victoria, so that it was going to be better adapted for the conditions that the peninsula would see in future. Claire, thank you. That will do me for the recap, and I'll go into my pre-arranged spiel about how we see often extreme events in the ocean as our focus here. And marine heat waves are a really common thing that we're talking about. When you look at the global ocean today, the most up-to-date data on the marine heat wave tracker says that 25% of the ocean is in a marine heat wave state today. That's about 20% in a moderate state, which is the yellow color, 3% in a strong state, and about 0.5% in the severe state, which is the darkest red. But a quarter of the ocean is experiencing extreme heat. But we also can get extreme cold. They're called marine cold spells. And on the marine heat wave tracker, you can also click a tab on the left-hand side where the map layer is displayed and have a look at where are the marine cold spells around the planet. And at the moment, less than 1% of the ocean is experiencing extreme cold events. If you were to take the marine heat wave tracker as the source of truth, you would say we shouldn't worry about cold events, and they're not making very much influence on our management of fisheries or conservation in Australia. But the marine heat wave tracker and the forecasts are fairly coarse. At the coast, cooling can be very, very strong. And the process that gives you cooling at the coast is called upwelling. On a global scale, the very strongest upwelling areas are found on eastern boundary currents, particularly off the west coast of the United States and South America, and similarly the west coasts of Africa and South Africa. And those are called eastern boundary currents because they come on the eastern side of the ocean basin. Very strong upwelling, very cold areas. Australia doesn't have one of those, as you can see on the left-hand map, but Australia has lots of little upwelling sites, what we call local upwelling. And these are places where temperatures can become quite cool quite quickly. And it happens quickly because it's driven by the wind. This upwelling is really important. It can break up strong marine heat wave events because it brings cool water to the surface. As you'll know, when you go swimming and you let your toes go into the deeper water, it's colder at the bottom than it is at the top of the ocean. And so that deeper water, when it comes to the surface, cools it and also brings more nutrients, mainly because dead things fall down in the ocean, and that's where they remineralize and we create new nutrient pools. So the upwelling brings the nutrients and the cold to the surface. They meet light and we get biological growth. And things like blooms can result after that. And we particularly need that movement of nutrients in order to get growth. In the southern hemisphere, the upwelling occurs when the wind blows along a coastline and we can get movement of water to the left of that wind direction. In the northern hemisphere, it's the opposite due to the rotation of the Earth. But generally in Australia, that means if we have a wind parallel to a coastline, you'll see upwelling to the left of that wind direction. When we get that upwelling, we get very dramatic temperatures. And so one of the strongest places for upwelling in Australia is off the Bonny coast. And that's shown in the left-hand side with a very dark blue colour. When we get a southeasterly wind in that region, that makes the ocean wind be blown parallel to the coastline with a southeast wind direction, and water moves offshore, dragging up that cool water. You can also see a small patch off the New South Wales-Victorian border, just below where it says Argo Buoy, and that's kind of the Gabbo coast upwelling area. That's also a combination of wind and current driven upwelling. When we get that cold water and nutrients, you can then see that signal in the phytoplankton or chlorophyll signal from satellites. And on the right-hand side, look where the areas of strong red are off the equivalent area of cooling. There's strong strong chlorophyll signals, which are called phytoplankton blooms in those areas where there's upwelling. And on the very right-hand image, you can again see in that Eastern Victoria region where the upwelling has produced this bloom. If you have upwelling, it can be a really important local refugia. In the Great Barrier Reef, there's some upwelling areas right on the edge of the reef break, which look to be generally cooler than average. And so that might be places where corals will persist longer into the future because they will be relatively cooler than surrounding areas. So the very left-hand figure shows in dark blue where those cool areas are. The middle plot shows the absolute temperature averaged over a period of years, again showing the shelf edge is just a little bit cooler. And the right-hand plot explains that if the mix layer is deep, then we won't get upwelling of cold water. But in cases where you can generate that water pushing to the surface, you'll bring up that blue water and it can mix in onto the continental shelf. If we know where these areas are, it can be very useful for planning our conservation efforts or for understanding how the impact might ameliorate warm conditions on aquaculture businesses. These things are much more ephemeral than the big heating events, and so upwelling is not well predicted in seasonal forecasts. But you can predict it a few days or ahead of time if you can have a look at the wind fields. And so that's the wind fields are not well predicted in the access models, and also the scale of upwelling is smaller than the pixels that we're able to predict in our large-scale forecasts. So if upwelling is less than 25 kilometres wide, we won't see it in our long-term forecasts. So you can use the wind direction because remember, water moves to the left of the wind direction in the southern hemisphere. And so in the example on the bottom, there's a high pressure system in the Great Australia Bight. And at about the 1 or 2 o'clock position of that high pressure system, the wind will be southeasterly, and that can blow against the coast and drag parallel to the coast and drag water offshore, as illustrated in the figure to the right. So by using our long-term forecast, plus keeping an eye on the local wind conditions, you might get a sense of when warming might be disrupted by upwelling, which brings that cool water to the surface.
All right, so I'll go through the current ocean conditions now that we've had a bit of a upwelling 101. I'd just like to mix up the slide order to keep Alistair on his toes, make sure he's paying attention. So the next sort of section of the briefing, I'll go through the current conditions around Australia at the moment, and then we'll have a look at the seasonal outlook for the next couple of months. Okay, so always put it in context of recent conditions. So January and February were actually not that bad. Often I present these maps and they're mostly orange or dark orange, but you can see on the top, January here is putting the last January in context of 120 years worth of Januaries, if you want to put it that way. So the dark orange colour, which you can see off the North Island of New Zealand, is the highest on record. Around Australia, that sort of browny colour is about what you'd normally expect. So up on the northwest shelf, January was pretty much a normal January for that part of the WA coast. Southern part of WA was a lot warmer. It was up in the top 10%, so very much above average. The rest of the coast was between average and slightly warmer than that. If you look over to the right, to this bar plot here, blue means cooler than the average, red is warmer than the average, and you can definitely see that trend there. This is January 2026 here. So nowhere near the temperatures we were talking about this time last year. And this is for this whole box here on average. So definitely warmer than you would normally expect for January, but not in the same, even the past 2 Januaries. If we look at Feb, those conditions continue. The southwest WA does back off. It's still warmer than you'd normally expect, but not quite as high as it was in January. Cool on the northwest shelf or around normal conditions, warm in the Coral Sea, so it's starting to ramp up in Feb, and then around the south coast of Australia, still warmer than average, though not record breaking. So looking over here, you can see again, this was February 24 and 25 right up here. We're back down here for February 26. So a lot of the heat we saw in the last couple of summers, it was already warm. And so once we'd got into summer, it was just heat building on top of that. And as Alistair said, we haven't seen severe marine heat wave conditions around the country this year. So taking a global picture, because what's happening in the Pacific and also the Indian Ocean influence the oceans around Australia. This is from the last week or so. Blue is cooler than normal. Red is warmer than normal. You can see it's mostly red. There are patches of blue here. And this blue out here in the Pacific is the breakdown of the current La Nina event. And I'll talk a little bit more about that in the next slide, or next couple of slides. So you can see this signature out here. That will gradually disappear in the coming months. And then around Australia, we can see cooler than normal conditions again up the northwest coast. There are warm areas down here of New South Wales and around Tassie, and we'll unpack that a bit more in the coming slides. I also put this in just to put it in context. So this is a plot from the European Climate Centre, and on here it shows daily temperatures for ocean temperature, so top layer of the ocean between 60 south, 60 north. And it just really puts in context the kind of background warming that's happening in the ocean. So this orange line or yellow line here is 2024. This grey line here, if you can see it in the background, is 2023. So it was leading into this year. The red line is 2025, and this is us here. So this is from a couple of days ago. This is where we are at the moment. So the oceans are warm, and we haven't seen, those severe widespread impacts we've seen in the last couple of summers around Australia. But I guess this is just a reminder that it is still really warm. So those plans are being put in place, those workshops, the coordination pieces, there's something to keep the momentum with as we move through this summer and potentially into next. Okay. So this information here is again the last week, but zoomed in around Australia. Same pattern, cool in the north, pretty average down the west coast, but then you can see it is reasonably warm on the east coast. So the Coral Sea, we've got anomalies of around a degree, so a degree warmer than you'd normally expect for this time of year. March is not typically the hottest time of year though for the east coast. That's usually January, February. However, we can see this warmth down here off the New South Wales coast and some off the south of Tassie. And as we'll see in the forecast, that heat is set to continue for a bit longer. We then look into the water. So now we're looking down, if we're on the shelf to the depth of the shelf, if we're off the shelf down to 300 metres, and just looking at whether that heat's just at the surface, whether we've just had a warm week and a bit of sunshine, or whether that heat's baked in at depth. If I flick between them, they're on the same colour scheme. You can see this heat here and the heat there. You can see some evidence of that at depth off New South Wales. And it is warmer at depth in the Coral Sea as well, but not quite the same signal that you're seeing at the surface. So for these areas here where there's a lot of eddy activity, that heat does extend into the water column. And then if we take that information and we say, well, how much of that is in the top 10%, which is the threshold for a marine heat wave, you can see patchy parts here in the Coral Sea that are showing up. But that warmth there on the New South Wales coast is showing up as a marine heat wave. And that is relative to March temperatures. So that's your baseline you need to keep in your mind. How did recent forecasts perform? Well, given there wasn't a lot of marine heat waves to forecast, it's good that we didn't forecast any. So we've got here, this is the February forecast that I showed you in the January briefing. So you can see those kind of areas in the Coral Sea that were showing up, but not widespread, not a huge area was covered. And this is what was actually observed. So the pattern's not quite the same, but you can see that it is very patchy and it's not a lot of it's in on the shelf. This area here of the southeast coast here, we did predict it's showing up here, and that has been quite a persistent feature. We've seen it for the last couple of months. If we look at our temperature anomalies, pink, anywhere that's pink is warmer, and you can see the model's done a pretty good job of predicting what was going to happen in February. And you can see that warmer area here off New South Wales, and also the area of southeast Tassie as well. The model has predicted those. So looking forward through March through to May. And so the global outlook, again, we often look at this from the perspective of what's happening in the Pacific, because that does influence ocean temperatures around Australia. So for the next, if you remember the first global map I showed, it had the little blue signature out here in the Central Pacific, which is the La Nina breaking down. As you can see, there's in this map here, which is looking forward now, that blue has disappeared. And so that's indicating the La Nina has broken down March through to May, which is what you would normally expect for this time of year for an El Nino event. Around Australia, you can see for the next 3 months, the model's indicating that warmth is just going to hang around off the New South Wales, maybe into Victoria and eastern Tassie. Everywhere else is warmer than normal, but certainly not extreme. So up around maybe 1.2 degrees warmer than normal, but we'll have a look at that as we break it down into months. So as I said, the La Nina event in the Pacific is close to its end, and all the models that the Bureau looks at are indicating return to neutral, so not El Nino, not La Nina by early autumn. So this is the forecast here from the Bureau's model, the one that we show all our forecast information from. And you can see this is the forecast here for March, and as we go into April, these lines that fall in this white area are neutral conditions. Once you get above this pink line, that's indicating an El Nino. So the caveat on this, it is a long way out to be predicting an El Nino with any kind of certainty. So the Bureau is keeping a very close eye on what the model is doing. And this is one of the criteria that we need to check, or we need to check off the list to be assured that a ENSO event is underway. So if we take what the Bureau's model is saying and we look at it with all the other models that we canvass from around the world, this is the forecast for April here. And you can see this is our model here on the top. And it's a bit of a mixed bag. There's quite a lot of uncertainty, but we're all in the neutral zone, which is this white area. Once we get to May, all 8 models are starting to point in the positive direction, but not all of them are entering into El Nino territory. And so when we were putting the slides together, we were talking about these forecasts. And I think in May we'll have a lot more, well, I know in May we'll have a lot more certainty whether it's likely that an El Nino is going to form and what the ramifications might be for that next summer. But at this point, there is a lot of uncertainty. It's very difficult for models to forecast an ENSO event this far out. So we're just keeping an eye on it, along with all the other criteria that need to be checked off for this event to be underway. I don't want to panic anybody, so we will discuss it in more detail when we get to the May briefing. The Indian Ocean dipole is neutral. That is what's normally the case for this time of year. It's above the positive threshold at the moment, but hasn't been above that threshold for long enough to be actually called an IOD or Indian Ocean dipole. Tropical cyclones, so just a recap on the season so far, WA have been very busy in terms of tropical cyclones. So of the 9 cyclones here, 8 have been in WA. So TC Koji was the only one that didn't happen in the western region here. So WA is batting and well above its average. Normally it's usually 6, but we've had 8. And so the TC season typically goes from the 1st November to the end of April. So the other regions have got a time to catch up, but the reason we talk about tropical cyclones is that they can really cool the ocean down. So you've got wind mixing with high winds, rain, and increased cloud. So we haven't the oceans aren't particularly warm, and so the importance of a TC is less, I should say, in terms of cooling the ocean. But what I did want to just reinforce is that the seasonal models can't predict tropical cyclones. They're a weather time scale. It can predict the conditions that might lead to more tropical cyclones, but it can't predict actual events. Okay, so rain and air temperature, we always look at these because if you're working really inshore, it's going to make a difference to your patch if it's going to be a sunny, warm days or cool, wet days. So these are the forecasts through to March to May on average. So it will depend on the month and whereabouts you are. But at the moment, the forecasts are indicating warm and dry in the southern part of the country and cool and wet. Cooler than normal and wetter than normal in the north. So that wetter signal brings rain, cloud, and cooler days. So, and we did see those cooler temperatures off the north there as well. So it's all related. Okay. So going into the next 3 months, given that we're halfway through March already, this is the forecast for the next couple of weeks. And so same format I've got here in the bottom. This is our skill, so how well the model performs for this time of year for these forecasts. Basically anywhere green, the model does a pretty good job. So on the top left here, this is our sea surface temperature, so top 1 metre of the water column. And then below that is our 300 metres, so 300 metre average temperature. So to the bottom on the shelf or 300 metres off the shelf. You can see here these warm temperatures here off New South Wales and Victoria, and this is going to be a recurring theme over the next couple of slides because you're going to see this feature here persisting and off South East Tassie, and you can see that at depth as well. So there's a warm eddy sitting there, and there's also warm temperatures at depth here as well. Coral Sea continuing to be warm for the next couple of weeks, and it is warm on the shelf, not so warm off the shelf. And the West Coast is looking pretty average for this time of year. So there are warm patches, which are probably eddies, and it's cooler here in the north. And you can see that at depth as well. Those cool temperatures, which is the blue on this plot here, down to the bottom of the shelf. So that then translates to marine heat wave likelihood, which is pretty low for most places. The places that do light up are parts of the Coral Sea, reflecting these temperatures here. And these two spots here, so New South Wales and Northern Victoria, and then further offshore from Southeast Tassie. So that's anywhere that's pink to orange is a pretty high likelihood the next couple of weeks are going to see marine heatwave conditions. And then when we collapse all that information down on average, this yellow colour here is showing moderate marine heatwave conditions. So you can see that in the Coral Sea, it looks like it's following the shelf there. And then we're up to strong marine heatwave conditions here off New South Wales. So that is relative to March. So it will really depend on whether March temperatures are a critical consideration for your business. So the hottest time of year in this part of the world is usually January and February, but it is still quite warm there. And you can also see that down off Southeast Tassie. We go through to April, you can see we're starting to see some yellow and white on our model skill down in the bottom left. That's showing the model has less certainty about what is happening in those areas. New South Wales, off the coast here, there's a lot of eddies there. So it is quite hard for the model to get the eddies in the exact right position, which is why you can start to see the performance dropping off. So same patterns as we were seeing in the previous slide, except the Coral Sea starting to back off. So we're now heading into April, so it's much cooler, or into autumn for Coral Sea. But this heat here down New South Wales, Northern Victoria and off Tassie is set to hang around. And so now this is quite a lot warmer. We're up to almost 3 degrees warmer than you'd normally expect for April down the coast here. And you can see that's at depth as well. And so if that heat is baked in at depth, it means you're not going to have just a week of, sea breezes is not going to disperse that heat. If it was just at the top, you might get that happening, but because it's at depth, it's harder to disperse that heat. And you can see here off Tassie as well. That translates to high chances of marine heat wave conditions for April. And you can see that down here, that marine heat wave signature with up to strong conditions here, sort of off New South Wales, northern Victoria. Going into May, it's the same pattern. So coral seas backed right off, but that heat is hanging around. So that is another consideration as well. Even though it's not the hottest time of year, it is significantly warmer than normal for autumn, and it's sustained. So it's that chronic low-grade heat stress and what the impacts might be from that. So you can see here up to 3 degrees warmer down the coast, same area, at depth as well. And you can see that translates to a high chance of marine heatwave conditions. And that area of strong marine heatwave conditions has been forecasted to grow actually here off Victoria. As you can see here, we're trying to predict further into the future, so the model's skill or performance has dropped off further. These white areas, again, in those eddy-rich fields. So I'll pass back now to Alistair. So that's the end of the sort of the outlook, and over to you.
Thanks, Claire. In the second briefing this year, we showed this sketch here, which talked about all of the kinds of things we might do to prepare for living in a changing environment. Claire and I call this our peacock plot, but it says what are the kind of things that should be a business responsibility, a sector responsibility, a state responsibility, or a national responsibility. And those responsibilities are underpinned by data and expertise that can be either short-term or long-term, which is the base of the diagram. When we presented it, we were talking about the marine heatwave response plans that have been developed by states, or the South Australian Algal Bloom Summer Plan, which was a government initiative focusing ecosystem restoration and research funding. There's also been recent activity in another class of activity with national strategies that are really focusing on how we're going to live in a changing environment with extreme events going on. And two documents I think are really important to be aware of in our ocean community. The first is the Blue Economy CRC and Seafood Industry Australia Futures of Seafood project, which is delivering a 10-year strategy for the future of seafood. The second one is the National Marine Science Committee is releasing the National Marine Science Strategy on the 26th of March this month. And both of these make large calls for national coordination around managing this changing environment that's affecting the ocean. I'm just going to point out a couple of things in each document that are worth paying attention to. One of the recommendations in the draft strategy that may become official when it's released on the 26th of March are that it's really important that we have a community that is able to provide accurate, reliable and actionable predictions to help industry, governments and communities plan for and adapt to climate change impacts. And that's a finding that's come out of a collective set of 21 white papers that were prepared by the science community around Australia across more than 40-odd institutions. So the kind of work that we're talking about here is helping to deliver on this national strategy of providing forecasting to help decision making. The second example was the Blue Economy Futures of Seafood project, and that's got 5 priorities in it that are needed to be fulfilled in order to make the most of our oceans over the next decade or so. And the fourth of those is called a National Rapid Response Capability, of which the forecasts that we talk about here are just one aspect. But if we're going to comprehensively respond to climate shocks, we will need all kinds of actors to be contributing to that system. And the early warning systems that Claire and I describe here are just one of them. Having threshold-based crisis plans, uniform communications, and a transparent response to the risks is all work that's ahead of us. So we're only taking it at first base at the moment. So as a result of the efforts of this community and others, I think we've got many of the things in place that can help us respond to marine extremes. Public forecasts, marine heatwave response plan, industry response plan, preparation workshops and materials, and a range of communication channels that are talking about extreme events in the ocean and climate change in general. However, in order to go from perhaps the surviving or the resilient approaches, in order to really get to thriving, I think some other elements need more attention. as Claire and I have talked about, our forecasts can only do some things at some time scales. And so we do need in-water information and real-time data. And that's provided by national coordination of monitoring through programs like IMOS. I think in order to efficiently respond to these things, we need the equivalent of bushfire and flood response teams in the ocean. These are incident management teams that are prepared ahead of time with understanding how we will respond as a national community to extreme events in the ocean. Why don't we establish a couple of those over the next year in different regions of Australia to think about coordinating national responses? And finally, we need much more effort into discovering which response options can actually work. And researchers can propose a bunch of options that might be suitable for ecological or social or economic responses, but testing is a very different thing to proposing them. And so we need to have our community reporting back on how some of these options are being used around Australia. And I hope over the next couple of years we see a lot of effort going into collecting and using that real-time data, testing the response of management teams, and really trying different interventions to offset the worst of these climate outcomes. Helping you with that information, it continues to be the FRDC Extension Officer Network, which is distributed around Australia. And through Jamie and the team, they're a great conduit for different information that you can put up to us or ask for from that team there. And in the chat, I'm pretty sure that someone has just been posting also the, they haven't, just some other associated stuff going in on the chat. Let me close there, Claire, say thank you to everybody, and I'll stop talking.
Thanks, everyone.